This video will show you how to perform a 2D pocket milling operation in Autodesk Fusion. In order to get started, we are going to show one change in order to create a color appearance change to a face. Select the face at the bottom of this pocket. Right click and select Appearance from the menu. From the options, scroll down, find the paint folder, expand the glossy folder, and find a red color to drag and drop onto the face. Select Close. Let's change from the design workspace to the manufacturer workspace. Here we're going to define our setup. Select Setup. In this scenario, we're going to select the new box point, the bottom left corner, verifying our Z, Y, and X directions. Select the Stock tab. Relative size box will be used. Under the stock offset mode, select no additional stock. Notice the stock dimensions updating in this menu. In post-process, select the name and name it with the last name with 2D pocket. Select OK. Now from the 2D panel, select 2D pocket. Select the tool. We will use a large diameter end mill, such as the 1/2 inch diameter end mill, in order to remove a lot of material efficiently. The rest of the values on the tool tab will be left at their default. Select the Geometry tab. Pocket selections, select the red face or the bottom of the pocket in order to generate, or even the edge of the pocket will also be able to be selected. The rest of the items will be left unchecked, such as stock contours, reset machining, and tool orientation. Select the Heights tab. We will leave clearance, retract height, and feed height at their default values, and we're going to verify the top height is set to stock top with a 0 offset, the bottom height set to the selected contours at an offset of 0. Move to the Passes tab. From here, most of the items will be left at their default. The maximum step over will be at 50% of the tool diameter, or 0.25. And from here, check the Multiple Depths tab. The maximum roughing step down is how much that the tool is going to advance down into, or step down into the part. Make sure that we change this to 0.25. So this is a calculation typically based upon the diameter. So since we're using a 1/2 inch end mill, this will be 0.25. And we will uncheck the stock to leave. If there's a value other than 0 inches, you can always select the 3 dots, enter in 0 inches as a stock to leave, and say Save as user default. So radial stock to leave and axial stock to leave should show 0 inches. The rest of the tabs will be left at their default values. Let's select OK. It shows a path that is being created and laid out by the pocketing operation. Under Actions, select Simulate. Select the Start button to watch the tool performance operation. Select the Statistics tab to see how long the machining time takes. Another way that we can utilize another operation is by right-clicking on the operation in the browser and selecting Suppress. If we wish to look at another operation, but yet don't want to delete what we've created, we can always suppress this operation. Under 2D, we will select the 2D adaptive clearing, which creates a roughing operation that creates a more optimized toolpath in order to keep from having any abrupt changes to the direction. So selecting adaptive clearing, the tool is already selected. Select the Geometry tab. Select the red face for the pocketing contour. Under the Heights tab, verify that the top height and bottom height are shown. Stock top with 0 offset for the top height. Bottom height is selected contour with 0 inches. Select the Passes tab. Make sure to check multiple depths and change the maximum roughing step down to 0.25. Uncheck Stock to Leave and select OK. Notice the tool operation has a very similar helical kind of advance into the part, but yet has a different tool path than the pocketing operation. Under Actions, select Simulate. View the simulation and verify the statistics. Notice the difference in the machining time. Exit the simulation. We are always able to suppress this operation. If we wish to see the pocketing operation once more, right-click and select the Suppress option. If you see the toolpath is out of date, right-click on the toolpath and select Generate. The checkboxes indicate that this toolpath is ready to be simulated once more and can be used in order to create our NC code. Press play to simulate, verify in statistics to see the machining time. Select Exit Simulation. Make sure to save your file